Not all fuses and breakers are created equal, and choosing the right type can make or break your electrical system's safety. And that's exactly what we're going to cover here in lesson number 2 of this Breakers, Fuses, and Overcurrent Protection playlist. My name is Nate, and welcome to the explorist.life Mobile, Marine, and Off-Grid Electrical Academy. Let's get started. So what are the different types of fuses and circuit breakers? Well, we have all of the fuses and circuit breakers here that we have in all of the systems at shop.explorist.life. And I think the best way to explain what they all are, what they're for, what they do, is to just sort of go down the line here and explain what we have, where it's used, their typical sizes, and their typical use cases, and I'm just going to start down here on this end. So what is an AC breaker? An AC breaker is pretty typical in US households in your just standard residential breaker box. They've got a slot here on the back where power comes in and a screw terminal on the bottom where power goes out, and that's connected inside by the breaker mechanism that will be connected or disconnected, connected under normal operations and then disconnected if you need to do maintenance, but more importantly, if there's an overcurrent event like a short circuit or the circuit is overloaded due to overuse. There's two different types of circuit breakers that we carry here at shop.explorist.life, and this is just a single breaker, and then this is a tandem breaker, thank you, and realistically it's just got two different circuits on there. So this is a standardized spacing in most breaker boxes, however wide this is, and this one's just got two different circuits. So that's realistically the only difference between the two there. These are going to be for all of the AC circuits in a system, and you can see that in all of our wiring diagrams at shop.explorist.life in the 120 volt AC breaker box that's protecting all the standard household outlets throughout a camper or off-grid electrical system build. So what is a DC circuit breaker? A DC circuit breaker actually works in largely the same way. Power comes in through one terminal and out through the other terminal, and the internal breaker mechanism will either connect or disconnect the breaker from flowing power. If you're doing maintenance on the circuit, you can disconnect power just by pushing the button, and that arm will come down indicating that the circuit is then broken. Or if there is actually a problem, whether you've overloaded the circuit or there's a short circuit, which is flowing too much power, that arm is going to be tripped by the internal mechanism without obviously having to push that button, and that's going to indicate that the circuit is blown. And then you can further investigate for a short circuit, or if you've plugged in way too many blenders to the circuit or whatever device you've plugged in, you just unplug those and then reset the circuit, and then don't plug in quite as much next time because that's going to overload the circuit every single time. What are DC fuses? So we have several different types of DC fuses here, and we're going to just start left to right. We have an A&L fuse here, and then this is one of the highest amperage fuses that we have in our systems at shop.explorist.life. And the way that it works is power is coming in one side and out the other side, and then there's a little filament inside of there that if there's too much power flowing, whether that be from an overloaded circuit or a short circuit, that filament on the inside is going to melt and it's going to stop the flow of power. Now, there's no way to reset this like there is a breaker, but this particular fuse is going to be used in a location where there's no way for it to be overloaded accidentally. That fuse needs to be sized so that it can work under all normal operating conditions, and is really only going to blow if you have a short circuit event. So in our system designs, this is always going to be the main system fuse. It's going to be on a fuse holder like this and is in this location in all of our wiring diagrams, and that's what we're using for that because it's a really high amperage device. Now, an alternative to this that you'll see in some systems that we don't have in our store because the fuses are not very available is a Class T fuse, and that's going to be used in a similar fashion and has a similar use case. The next one is a mega fuse, and it works in largely the same way. Power is coming in one side and out the other side, and there's no window on this one, but there's still a filament on the inside that is going to melt if there's too much power flowing. And I think some people think that there's a downside to not having a window, but it's really easy to test if a fuse is blown. Well, because you're not going to have any power coming out the other side, and we can use a multimeter to sort of test if there's voltage on one side and there's no voltage on the other side. It's pretty easy to just narrow it down to that fuse is probably blown. This fuse is used for all of our larger component circuits in all of our systems. So this is going to protect the wire that's going from the Lynx distributor to the Victron multiplex inverter charger or the solar charge controller or the DC to DC charger. So anything that's a 6 gauge wire or a bigger, higher amperage device is going to get this, but not quite as high of an amperage device as this usually. The next fuse that we've got to talk about is a MIDI fuse, M-I-D-I fuse. And it's literally just a smaller mega fuse, more or less. Power coming in, power going out. There's a filament inside that will melt and shut off power if too much power flows, whether from a overloaded circuit or a short circuit. Now, the MIDI fuse is typically going to be used, I think the most popular use case we have for it is underneath the seat of a Sprinter for DC to DC charging. There's a bus bar under there, and this is just the size that they use for that, and so that's usually our best use case for that particular fuse. We also use the MIDI fuse in place of the mega fuse, depending on sort of the system design that we've got going on. So if we're not using the Victron Lynx distributor, and instead you're using the Blue Sea Safety Hub or the Tiger Expedition UFO 200 like we have in our Explorer Mini system, the fuse holders of those two devices, they just accept the MIDI fuses over the mega fuses. And so since that's what that particular device calls for, that's what we're going to use. The next fuse that we're going to talk about is the blade fuse, and this is very typical blade fuse. Any car is pretty much going to have these up underneath the dash. I think anybody with a car has probably used these or changed these, and these work in similar fashion to all the other fuses we've talked about. Power goes in, power comes out, and there's a little filament on the inside that will melt and stop the flow of power if the circuit is overloaded or there's a problem and there's a short circuit. Comes in all kinds of different ratings. Generally, let's call it 1 amp to I think 30 amps is the biggest that we carry. The other fuse that we're going to talk about is this MRBF fuse. It's also called a terminal fuse by some manufacturers, and it's kind of interesting because it works in the same way. It just looks kind of funny because you've got this metal piece on the top and this metal piece on the bottom. And there's this little white piece on the inside. It's probably kind of hard to see. But this metal piece and this metal piece is sort of like this metal piece and this metal piece. Power comes in one side, power comes out the other side. And the filament is actually right there in the front, and that's what's going to melt. So power comes in this side through that filament and then out this side here, and it acts in the same way. We use this one a lot in conjunction. So here's the MRBF fuse holder. And we'll talk about the fuse holders later, but we use this, this combo a lot for alternator charging. This works really well for attaching to the top of a factory starter battery in pretty much every vehicle, every truck, every van, et cetera, and it protects the wire coming from the starter battery to a DC to DC charger. That's where we most typically use this one here. The last fuse that we're going to talk about here is a PV fuse, and this is installed in a solar array on solar arrays that need them, which we'll cover later in the academy. But power comes in this side from a PV connector, and power goes out this side from a PV connector, and it's going to protect solar arrays that need them. And there's a fuse on the inside. We can unscrew this housing here, and the fuse on the inside looks like so. Power comes in, there's a filament on the inside of this that melts in the case of an overcurrent event. power goes out here, and then, you know, it's just, you've got that hole on the inside, and this is what your PV connectors are actually attaching to. And these are great. They're waterproof, they're weather resistant, they can be installed out in the elements, just the same as your PV connectors, because that's what it's designed for, and it's great for that. The remaining items on this table is just our fuse holders, which we're going to cover in an upcoming video in this academy. So now that you know the different types of fuses and breakers and sort of how to choose the right ones for your system, we're going to be covering where fuses should be installed in your electrical system. So click up here to watch, and I'll see you over there.